Good day, everybody. We're here. It startup and innovators on Atlanta Discuss. Yes, that's our new baby, and this episode 6 in startup and innovators. Sometimes we have a startup person for you. Sometimes we have an innovator. So again, today we have someone who is a startup and who is also an innovator. He's almost a 5-in-1, 6-in-1, even 8-in-1. By the time you see everything we're putting together today, he's a fantastic guy, a Nigerian. Surprisingly, I'm sure most of you will feel he's a Nigerian, he's from Bauchi, great guy, fantastic guy. So today I introduce to you Ambima Buzhyason. Did I pronounce it well, Ambima?
Buzhyason.
Buzhyason. All right, thank you. Welcome
Yeah.
to Atlanta Discuss Startup and Innovators.
Yeah, thank you.
All
It's a
right.
pleasure to be here.
Oh, we are excited too.
Yeah.
You have fantastic pedigree.
Yeah,
So I
thank
mean,
you.
Bima is a biomedical scientist. He's an AI and data scientist. He's a cybersecurity strategist, healthcare innovator, visionary leader, etc., etc., etc. So, Bima, it's your story. I'm an apostle of telling your story yourself. You understand? So, tell us, who are you? What are you? And everywhere you have a specialty in. Let me allow you to do that to our viewers. So you have the floor, Ambima.
All right. Thank you again for inviting me to this platform. I've heard about it, and it's a very good platform. Thank you for giving us the voice. To begin with, I come from a very humble background. Of course, we have all been here from Nigeria. I've been in the U.S. for quite some time now, over 15 years.
Oh, wow.
During my time here, I went through a lot of schooling as typical
Mm-hmm.
Nigerians that I know
I
of.
am.
A lot of us here are very, very academically inclined, and I took that route and I represented the country to the best of my ability as I could.
Wow.
I started with a bachelor's in biology with distinction, and then a minor in chemistry as well. The reason I got that distinction was because I created a plant animal hybrid that was capable of basically photosynthesis. And why did I do that? I wanted to study energy systems in a way that we could either capture sunlight more effectively and produce more food. In fact, that's another thing that I would rather talk about in another platform, but that's one of the things that I've been working on. But it's an invention on itself that I haven't even introduced yet, but we'll talk about that maybe another day as well. Moving on, I went on to study my first master's degree in molecular biology with emphasis on cancer and genetics and epigenetics. So during that time, that's when I got so much interested in anything computationally, because when we were dealing with DNA sequences of cancer patients or some of my experimental subjects, it's really, really complicated. It's very hard to just sift through a bunch of letters like A's and C's and T's and G's, the ACTGs, basically the genomic code. You cannot really do biology today effectively without understanding computational science. So by diving into cancer genomes and trying to make sense of what sort of genes were expressed and which ones were either silenced or dysregulated in some way, we needed the help of computers. And so the problem was, as a biologist or a geneticist, I go to a computer scientist who purely is mathematical in nature. And when you tell them to analyze a biological data for you, they will do it from a mathematical standpoint. However, when we're dealing with biology, 1 + 1 does not always equal to 2. So I was met with a lot of conundrum where I understand the concept of why they were doing it the way they were doing it. However, they were not answering the biological question I was trying to resolve. So I took it upon myself, started learning the computational programming, wrote my own scripts to analyze the data that I knew were taking into account some of those biological concepts, and of course the caveats as well. In that sense, I began to basically code and create pipelines of like sequence analysis, computer programs in R, Python, MATLAB, all sort of different computational programs and statistical analysis softwares that I begin to even share out to other laboratories and other researchers and collaborators. So I really got more into the computational aspect of things a lot more than the wet lab aspect. After finishing that master's degree, I went on to get an MBA in healthcare management. And after that, so I pivot completely to a doctorate in data science and cybersecurity, given my computational background. And of course, I have publications from my master's, my first master's degree, including basically a profiling of a very, very pediatric form of cancer known as Langerhans cell histiocytosis. This is a cell that this is a cancer that affects kids between the ages of 0 through 4. It can occur in adults as well. However, majority of the patients that really tend to be affected are children, and the mortality rate is really high. That's because there's very little research or knowledge out there as to how to basically address it. So what I did was I profiled the genetic landscape, the genetic landscape, as well as the epigenetic landscape of the disease in search of specific areas or biomarkers, things that we can use to predict or effectively target, do like more personalized therapeutics for that type of cancer. The reason why that type of cancer can also be such a big model for other type of cancer is that it's a blood cancer. It affects certain types of blood cells, your immune cells, dendritic cells to be precise. These are your big macrophages or large eaters. They clean up your system from all sort of toxins and, most importantly, diseases. When we get infections, these large cells are your first line of defense. They go there to help clean and protect you. In Langerhans cells histiocytosis is that we see patients showing where you have completely growth of this and disruption of that immune response mechanism. As a result, children tend to die really early because, again, first, their immune system is not fully developed, and now they have a disease that basically targets specifically their first line of defense, which complicates matters as well. So that's just the educational background. I can talk a little bit more about my work, a little bit, I guess. Feel free to interject me.
Yeah, no problem. No, we'll get to your work later. No problem.
Yeah.
I just wanted you to tell us your story, where you're coming from, and you've done that very, very well. Yeah. I mean, like I said, Ambima is from Nigeria. It's from Bauchi State, and fantastic guy, you can see. We're proud of you, but let's go into the nitty-gritty. I know there's a lot about data science in your work and biomedical science. So I'm wondering, can you share an example of how you have applied the data science technique to your biomedical problem-solving scenario?
Yes, currently I actually hold a patent for, it's been issued as patent pending for a blood sugar monitoring device. It's completely wireless, and one of the ways that I utilize data analytics in this case is that I use computer algorithms to come up with a precise way of, so basically in chemistry, for all of us who have a chemistry background or some sort of understanding of the light, the emission absorption spectrum of molecules, when you shoot light at anything, it absorbs a specific frequency and reflects back at a specific frequency. So what my invention does is that by controlling the intensity of how much light I shoot at the molecule glucose at a specific time, at a specific spectrum or area, I'm able to then take the difference between how much light I shoot at that molecule and how much light is reflected back to me. And that calculating that difference, I'm able to tell you how much glucose molecules are in a given blood sample. Why this hasn't been done already before, it's a mystery to me. But however, there's It's not something that I would say is out of this world, but I have had this idea for quite some time, over 10 years. And being a student at that time, I didn't have all the resources. So what I did, I keep on writing it down, keep on developing it over time. And fast forward to 2 years ago, I incorporated the company. I basically went ahead and filed for a trademark for even the name Nosemic, which I actually coined is a term. My company is called Nosemic Incorporated, and Nosemic basically came from normal and semia, so normal blood. I come up with the term Nosemic. It's trademarked also, and I've already gone through the trademark examination for that. And the software that runs Nosemic or the Nosemic's SGM device, which is the smart glucose monitoring device, it's called Smart Simic. That term also is also trademarked as well. So how did I use data science in this? It's basically mostly computer algorithms and precision medicine and personalized medicine and understanding of basically how we can leverage really data analytics and advanced AI systems to create sophisticated medical systems and devices for personalized medicine. In fact, one of the things that set us apart, there are big players in the business of diabetes. I mean, you've heard of probably Abbott's Freestyle Libre or Dexcom CG7. All of these are big players in the business. They have a lot of money that I do not have. But one of the things is that our device will actually, for the first time, be 100% non-invasive. All of their sensors include some sort of a pricking or where you have to replace it over time. It's very bulky, cumbersome. Our device, Nosemic's SGM device, is very miniaturized in nature, and it's precisely located in one part of the human body that does not have a bone. Nosemic's device will clip on in an earlobe, just because, again, to increase our efficiency and accuracy levels, it's basically a clip-on device that's connected or tethered by some sort of medical grade silicon as well as magnetic components that basically holds it in place so that it doesn't fall, but it's very precisely just a clip-on and customizable in accordance to a person's skin tone. Let's say you don't want to appear that you have an earring on, you can just customize it, choose your own custom colors. If you want it adorned some way. So we basically make sure that everything that we're thinking about, part of us is precisely designed for the individual to make sure that we are customer centric, but most importantly, the patient's convenience and ease of use are key to what drives our innovation. And especially the use of data is to understand those kind of like key nuances that might have been ignored by the big players in the business so that we can create something that's unique, affordable, and doesn't require a lot of work to basically use.
Let me ask you this. I'm going through all your work right here, and I mean it's impressive. But what role is blockchain? Because one of your areas of specialty is a blockchain for biomedical and environmental sustainability. So I mean, I also see tokenization because I read about blockchain. I don't think I'm an expert, but I understand the language. So how does this correlate with everything you're doing in biomedical studies, in cybersecurity, in healthcare, and general innovation? What's the role of
So blockchain is very important. In fact, I work for Blockchain Laboratories as a consultant data scientist in charge of R&D for a while. One of the things I do is create models, and one of my models is basically geared towards protection of biodiversity, carbon sequestration, as well as energy preservation. Now, how does that play into the bigger concept of course, sustainability, biomedical innovations? Is because using global information systems, or GIS, I'm able to, for instance, track human activity in the Congo, human activity in Borneo, and then of course in the Amazon. Those we call those three the craylons.
Borneo, that's Indonesia, right?
Yes, Borneo in
Indonesia.
Indonesia,
Indonesia.
and Congo,
Africa.
and yep, in Africa, and then Amazon in Latin America.
Brazil, yeah.
Yeah, so basically we have projects there that allows me to use satellite imagery to determine human activity, biodiversity protection, including, for instance, bees, species. So I'm able to actually categorically categorize what kind of insect species we have for inflorescence. Those inflorescence are very important because what we've also known from some of my models and research, I've identified that bees can only, for instance, fly up to about 1.6 kilometers. Anything past that, they become fatigued, and thus anything that is farther away from them, really what we see is that the biodiversity begins to diminish if the bees have to fly longer than 1.6 kilometers. So what we have seen is farmers who actually keep bees within their own farm themselves tend to increase productivity up to 40%.
Oh, wow.
Of food. So this is another knowledge that a lot of African and the third world farmers are not being told, and a lot of big business is not being told. And so what I have been interested in is not just medical innovation, but really a globally self-sustaining global system, especially for African countries or the developing world. I would like to see them food, basically self-sufficient in food production, clinical systems. In fact, part of my innovation for this medical stuff also goes into accurate diagnostics. The idea is that certain diagnostic tools that we use tend to require a lot of basically preservation, refrigeration, which may not necessarily be available in those areas. So I'm creating things that are temperature resistant using AI systems, or things that are self-containing within, so that we can transport them and have a good shelf life that would not interfere with those accurate diagnostics across the globe as well. And those decentralized systems allow us to not be basically the blockchain aspect of it. Now, to answer that question very clearly, is that blockchain allows me to create decentralized apps, or dApps, as we call them. Those decentralized applications can be accessed anywhere. They are free from interference by bad actors and government regulations that may not necessarily be in the best interest of the people that they are being governed. So because of that aspect, that decentralized component to it allows it for anybody with internet anywhere they are to have access to it in just a click of a button, and free of charge, without any high taxes. So basically, I call it internet without borders. Like, you've heard of doctors without borders.
Yes, absolutely.
So it's basically delivering the same aspect, caliber.
In French, they call it Médecins Sans Frontières.
Yeah.
All right, cool. No problem. I mean, I have to thank you because you're using a language everybody can understand. I like that, because I know if you really want to use the jargons that comes with it, we might all be confused. So, but for the privilege of those that are watching, I'm sure your language is simple enough. I like that. So I have two quick questions for you before we go into details of your patent. So the first one is, how do you think healthcare innovation can be accelerated through collaboration between industry, academia, and government? Because that was the last thing you were saying. That's how do you think, especially with third world countries, not necessarily Africa, but third world everywhere, but okay, let's say Africa, how do you think there can be collaboration?
And I think it's there's this misconception that academia, business, industry, and government are completely separate from each other. And there's the good old saying that one hand washes another. I believe that through collaboration and actually empowering institutions to be the breeding grounds for innovation, that we can achieve those talks about food sustainability or sufficiency, industrialization, and infrastructural development. And I think sometimes again, I use Africa because that's where I am from.
Mm-hmm.
Sometimes we hyper theorized everything, and the practical aspect is missing. And yes, you'll find very brilliant Africans with lots of, knowledge about a lot of things, but the practical applications of those knowledge is sometimes quite lacking. And in my
Why is
opinion,
that? Why is it like that? Why is it like that?
because the system that we have created, it's more about what you
Theory.
know rather than what you can do.
Oh, okay.
And so it's good to know, but
Mm.
it's even better if you can do.
Practice. Mm.
Um, and so the way we can actually fix that is that make it where we learn by doing. So instead of learn by itself cramming and all of that, people used to think, you can cram. We got people that I know, even just to talk about some of my Muslim friends, they can recite the whole Quran from
Mm.
back to back. That's
Mm-hmm.
impressive.
Mm-hmm.
Right? But I'm thinking also, I've had this, they can use the same thing in class. People can cram the whole book and spit out the same thing for you. But when it comes to understanding, improvisation to me is the key. If you understand a concept to a point where you can improvise, that means you can break it down into pieces, come up with your own version of what you've learned.
Mm.
Then you are the pinnacle point of learning that system. Then your chances of recreating or even doing something better or making something out of completely, that's in fact the hallmark of innovation. In my point, improvisation is the hallmark, is literally the grandfather to any innovation. Once you can destroy a system, put it back together in your own way, then you are at the height of understanding that system. Because if you cannot improvise, you might as well just be a copycat, right? That's basically what you're doing. But if you know every aspect of a system, like I used to say, you give me a box, I'll break it. I want to know what's in, and know each component. That way, I can put it back together, and perhaps I can see some of the flaws and then fix it that way, and maybe improve the system. So our emphasis should really be geared towards practical knowledge, improvisation, helping students learn by actually participating. And we should be praising students who invent, who are trying. Yes, there's failure is there. And sometimes we tend to think of failure as the end. And so we are so harsh. And in fact, there's this the African minds, if a person fails at something, we look down on them, we
Mm.
criticize them, we make them feel so bad to a point where we are losing a great aspect of lesson learning from those mistakes. A person who actually have an open mind and is comfortable failing, the sky is the beginning point for a person like that, because then they will never be defeated. If they fail and they're comfortable to look at what they did wrong and try to rectify that system, then you will not have a problem, because they will figure out exactly why it failed in the first place and create even something better. Some of the greatest inventions in science come through mistakes.
Mm.
And when we
Good. Yeah.
teach a culture or preach that sense of it's okay to not get it right the first time, it's okay to fail the second time too, then we are losing that aspect of pushing people to do to learn by doing. Because
Okay. Let me. Sorry to interject you.
no,
Are
you're
you?
good.
Yeah. Are you collaborating with any African country on any of your patents right now?
In fact, I have been trying to work with people back in Nigeria. I do
Mm.
have a school there, and part one of my school is a model. It's called a Model Academy, and it's mostly a practical. It's a elementary school right now, but
Mm-hmm.
I embody the learning by doing aspect. I want them to do some experiments. When they learn about certain physics concepts, they need to demonstrate it. They don't
Mm.
just learn to do the math or calculate it, set up those systems using the same principles that people learn. So that's one aspect, but I intend to actually in one of the aspects of nosemic is accurate diagnostics. One of the things I'm working on is a few other partners that because I haven't finished up the system yet, I would not discuss directly about here, but I am working on trying to increase basically the lives of people back home by making sure that we have good diagnostic tools and things that can basically be taken back to Nigeria or any other part of Africa without any issue, because a lot of people die from like misdiagnosis, given the wrong medications or things like that. So I'm really trying to get some of these things to collaborate with even the government there, especially for satellite. You know that Nigeria's satellite was initially being monitored by the Chinese government. That to me, I mean, we're just giving them our national security at the hand of another adversary. Yeah,
Wow. Can you
So
imagine that?
because it was set up by them, they built it and they have to show the teams how to. Of course, it's not. I don't mind collaborating with other countries, but I'm just saying that to improve our own self-independence, we have smart people that can do those things instead of going in the sense that, there's that saying that a prophet is without honor in his own town. But that is because we do embody that. We always think that something outside of Africa is better, right? So we tend to go buy outside, bring everyone else. Well, right in front of us, everything we need is
We
there.
have the solution right in front of us. So,
Exactly.
wow.
So I would like to encourage more collaboration between, the government, industry, as well as the universities in the developing world, because that is the key to self-sustenance and sufficiency.
Well, they watch this program. Atlanta discussed initially. I mean, on Fridays, we do all this political interview, but Wednesday is for startup and innovator. So I know government people watch it. Trust me. Well, after this interview, I mean, I will do my best and take Atlanta discuss as your partner also, because we like what is good. We like the fact, the honest. And one of the reasons why we do what we do is to propagate the Nigerian gospel in the positive way. I'm proud of you. We are proud of you, and we're overwhelmed. You see, I was listening to you and it's just unbelievable. So your elementary school is what part of Nigeria is it located in?
It's in Tafawa Balewa, the home
Oh,
of
about Prime
Sir
Minister,
Abubakar Tafawa Balewa, the first and only Prime Minister of
Minister in
Nigeria.
Nigeria. So your school is
Yeah.
in Tafawa Balewa local government.
Yes, it's
Yeah,
actually in Tafawa Balewa town.
Tafawa,
Right,
Balewa. Interesting.
the local government headquarters.
All right. So,
Yeah.
like I said, Ambima is from Bauchi State, so you guys should know. Fantastic guy. So let's debate again. Let's talk about AI. Yeah.
Yeah,
AI everywhere, Chat GPT, that GPT, the Chinese just came up with their own.
deep
It's
sink.
yeah. So every week something new is coming on. So my question is this, yeah. Two
Yeah.
questions. I really want to talk about your patent, but so this is gonna be the last question before we go to your patent. Now, this is two in one. Is AI a positive or a negative? Do you understand? That's my first question on AI. The second question is, yeah, with your expertise on AI, where is Africa in all this? I know the Chinese are like in front now. The Americans have been there for God knows when. I'm not really bothered about what Europe is doing, you understand? But where is Africa? And with people like you, can you leapfrog it if you get the requisite push? Over to you, Ambima.
Okay. Thank you. Those are really very important questions. And I would like to say I am very glad you brought those two questions up to my attention. So first, AI itself, just like any tools in human history, it's neither good nor bad. Now, that's the philosophy aspect of me talking. I'm the, the philosopher aspect, because AI is just a tool. How you use a tool, it really depends on what your end goal is. Now, can bad actors take AI and turn it into something nefarious? Absolutely. That's why we do need some regulations and really solid regulations around it. Now, AI itself can be a force for good. In fact, I am part of the United Nations AI for Good initiative, where Our goal is building models, using it to solve complex human problems, weather monitoring, modeling of biodiversity protection, increased food production, energy capturing, all sort of things that basically conventional computational powers are inefficient to gather some of those really intricate data points that could help us leapfrog from where we are to the next step. Another thing I want to emphasize is that just like the internet boom and the dot-com boom, AI is going to be the next big thing, whether we like it or not. AI is here to stay, and it's going to replace a lot of certain things. So my advice to anybody, it doesn't matter what field of work you're in, you definitely need to learn AI, or at least be familiar with how you can use it to improve your own work. As far as where is Africa in this, I've been actually in touch with a lot of young and upcoming Africans. I've had people reach out to me from Nigeria, from Cameroon, that they have their own ideas. They've been learning these things, and they see me on LinkedIn, or have read some of my watch some of my YouTube videos on some of the key things I talk about, including using AI for genetics, using AI for biodiversity protection, using AI for energy capturing, or deep system designs. Now, there are a lot of African innovators out there, and I think a lot of the time that what I feel is, as an African, speaking from heart, is that we feel like the government doesn't help support us as much. See, if you look at the US or Europe or Asia or other countries that are able to bring forth this big, they're not doing it on their own. The government is providing that conducive atmosphere of support. It encourages that competition. It creates either funding opportunities or even some sort of help in setting up those ideas and helping them run it to the point where they will improve the people's livelihood. Now, if we create something like, I'm sure, African governments have had their own ideas here and there. We've had, probably there's maybe some countries may have, a department in charge of AI or a minister in charge of AI. What I will say is that there are a lot of African efforts that are trying to adapt these things. If those people in power are listening to what you're doing here, this is very important. I think they should take it a step further. Begin to hold competitions. Like we have hackathons, right? Bring people in with different ideas. If you like, let's say our country's major problem is electricity, power, right? Come up
It's a
with
problem. It is a problem in Nigeria.
yes.
We have been
So
sitting around 4,000 megawatts for God knows how long.
yeah.
You know,
So to improve such a system, bring in the best of the engineers, electrical engineers, computer scientists, programmers, dig through the system, look at what resources Nigerian have, and how can we basically use all at our disposal. By the way, we do have all the resources at our disposal to make it where we will not have a power outage, not even a single second. And yet we don't use it. We have plenty of sun. We have water everywhere. We can build the dams, but
yeah.
so many resources that we can use. We can even build clean nuclear powered resources and energy like generators that can help us sustain everything. It's not that we don't have the money to make it. We have the minerals to build those things. We have some of the largest deposits of all of these rare earth minerals that can help us build these things with no issue. We have uranium, which is one of the major things there, and our neighboring Niger that even, and Chad and others that we even export electricity to. They have some of the highest deposits of uranium. France was tapping from it for so long. We need to get our hands there and do what is for our people. We have the resources. We can bring a lot of people together and they can come up with a good solution. And all we need is the backing of the government with a good policy behind. And really, we don't want all of these corrupt means. Because if we succeed together, we wouldn't need people to be paid because everyone will be successful, everyone will benefit. If we have electricity endlessly, people would run their business anytime. There wouldn't be poverty for people to have to try to kidnap or kill each other because they are hungry. There's a way we can solve these problems. It's because our greed and I don't know, perhaps if not me, then no one else's attitude is not helping us.
Interesting. Yeah, I mean, I like the way you put it, But unfortunately, it's failure of leadership. There's nothing to be diplomatic about. There's a failure of leadership. I mean, in America, 7 out of 10 Black doctors are Nigerians. You
Yeah.
understand? You are a Nigerian. Yeah, you're as good as it comes when you talk about research. So, I mean, we're going to go into your patents now, and people will see that. I mean, I'm sure if you are Russian or Korean or Malaysian or Iranian, you'll be living in your country, with all the support you can get. Unfortunately, we are still crawling, circumnavigating the facts, and until we learn to put square pegs in square holes, it might just be an effort in futility. But
Yeah.
we are positive. The essence of startup and innovators is to show the world and Nigeria that, look, no excuse. These are
Yeah.
people that can do it. You understand? This is
Exactly.
Ambima. You want to build this, build that, and from all intents and purposes, you're a data scientist, cybersecurity strategist, healthcare innovator, Okay, let's go to your patents. Let's go for the jugular now. How many
Yeah.
patents do you have? Can you itemize them one by one? Tell us what it's about and all that. So you can say,
So right
yeah.
now I do have one major patent
Mm-hmm.
because I try to solve my problems one at a time.
Okay, brilliant.
I do have two trademarks,
Two
all tied
trademark.
to
Okay.
diabetes right now. I
Mm-hmm.
have a few other ideas that I'm doing patent pending, so pursuing patents for them, including dealing with tuberculosis, non-invasive diagnostics of tuberculosis. TB is one of the WHO's it's on the radar for WHO to eradicate it from the world, and I hope I will play a role in that with the new diagnostic tool that I'm about to unleash. Another part is that I have other ideas about green energy, energy capture, solar power. I mentioned a little bit earlier about
Mm-hmm.
creation of a plant hybrid. A plant bacterial hybrid was a project I did when I was an undergrad, which earned me a graduate, bachelor's degree with distinction. The reason for that is to create basically plants. One thing people know is that microorganisms like bacteria really double really fast, they exponentially.
Mm-hmm.
So if we can turn those things into solar energy capturing machines, you can imagine solar cells that are self-replicating. And so that's one idea that it's already, in fact, if you go to my university, my former college, Columbia College today, it's archived in the library. You can even look it up on the Columbia College website. It has my name on it and what I did for that, for the cloning. I cloned what's called a B. japonicum or Bradyrhizobium japonicum. It's basically a primitive plant that is capable of photosynthesis. So what I did was I took the actual photosynthetic gene or protein in charge of photosynthesis from that plant, inserted in E. coli, localized exactly where it's located in the plant based on which part of the E. coli it was residing, and determined exactly the size and the function using what we call immunogold. So I use a gold particle because gold particles are shiny, and when you put them under electron microscope, we can easily see exactly where they are. And so with that, I was able to determine what it does and what kind of functions we can use in terms of capturing energy. So you can imagine we have solar cells that today they're still fairly efficient, but not that very efficient, because if you're an engineer, so I can imagine if you have to put in a lot more energy than you get out, then you're not that very efficient. And what I'm trying to achieve is that if we can create solar panels that literally require zero input, then you could achieve almost nearly 100% efficiency. And so those are some of the kind of ideas. And I actually want to target that specifically to the developing world. Another thing that I have been working on is basically an incinerator that also creates really that actually creates an electrical energy. What I realize is that a lot of the developing world, we have so much trash, so much dirt that's stinking in the major cities. To keep them clean, why don't we take them clean, keep them clean, incinerate them in control settings at high temperature? That temperature difference can be captured and we can transform that into electrical energy. So using one stone to basically kill two birds at the same time, keeping our cities clean and providing energy in return, as another alternative. Other things that I've basically looked into is, for instance, like a differential diagnostics, which is there's so many diseases that basically share a lot of symptoms in common. So how do we know what is the actual cause of a given symptom? There are ways that we can do that, and a lot of the times it's easy to miss some of those subtle differences. So one of the things that my company is mostly geared on, that's why I call it normal blood, is because our idea is to look at the whole giver of life, blood, and look at everything that we can do to basically differentiate specific things that each one of the pathogens that I have looked at. I actually, my first master's, as I mentioned, was in molecular pathology with specific emphasis on cancer and cancer epigenetics. However, as a pathologist, one of the things is that every time you have a foreign object in your body, it triggers certain response, and those responses are specific to specific type of pathogens. Your body's MHCs, what we call a major histocompatibility complex, it's just one of those remarkable things about the human body, that it's capable of recognizing even the most foreign object and adapting to it and creating specific molecules to mimic just that. So that's why, even if you've never experienced it before, you go to a place, you get some foreign object like an alien disease, our body will still find a way to adapt after 7 days to come up with a way to basically address and mimic it and contain it. So using those kind of specific responses that our body gets, I am looking into ways that we can basically take those things and create differentiated, personalized diagnostic tools using AI capabilities, ability to learn and self-replicating systems to basically make those things possible. So those are some of the things that I've been interested in. Of course, as well as mineral exploration to create energy. We have a lot, like lithium is one of the major things that big battery factories here for electric cars are using. Well, Nigeria has a high deposits of those things, and I want us to be able to explore, process them in Nigeria, make those batteries and export them out. Instead of get the lithium, send them out to someone else, they manufacture, process it, sell it back to us. It's at triple times the price. We can be doing that to ourselves. I mean, at some point we have to be like, okay, this is a little bit too much. It's enough is enough. We can do this here. And if someone wants to work with us, we should welcome people who are willing to invest in the people, right? If you're gonna work, if you're a European, an Asian, or Latin America, wherever part of the world you want to invest in Africa and really want to help us succeed, then make sure you build your factories there, hire the people there, make sure you pay them fair wages, and of course, then we can work with you. I'm not against that. It's just that when we have people coming in, take the resources, go to another country, make money up there, employ the people there to process, and then come and sell it to us, of course, we're not going to be self-sufficient. How do we become self-sufficient if we can't even basically process our own things? We can't hire our own people, even though we have all the resources on the ground.
Wow, wow, wow. I'm dumbfounded here, but I just have to say fantastic, fantastic. The only thing I can add to all this is, has it been financially rewarding?
Well, that's why we're here. So as a start, so,
I have to ask,
financially, it's been challenging. I mean, now imagine I have to do everything from scratch, right? So I code my software by myself. I design the device for the patent. I apply for those things all by myself prior to forming or even getting any publicity. In fact, I had to do a lot of the groundwork because I have this philosophy. If you're growing and you want to make sure you have some teeth before you announce that you're growing, or else you never know, the weed may just come and basically overpower you. So to avoid those things, one of the things I had to do is do a lot of the groundwork and protect my own intellectual property first before I begin to make noise about it. So financially, it's been challenging because I have to use my own funds to do all these things. So now, as a recognition of that, Start Engine, a Silicon Valley based crowdfunding venture capitalist company, have actually signed me up for basically a crowdfunding campaign. Their CPAs are in charge of all of the paperwork. They're managing all of the caps tables. So the goal is to take NoCimic, which is of SGM device with the software Smart Simic, to Wall Street. And to achieve all of those, we're doing this fundraising campaign through Start Engine. Our goal is to first, the whole overall amount that we're trying to raise with Start Engine is 5 million. However, Start Engine's policy demands that I should at least reach a threshold of 300,000 US dollars from either the people that know me or direct connections, and then they will then blast out my ideas and a campaign to their own team of over 2 million investors. So that's where we are now. That's one of the reasons I'm doing this, is to spread the word out there. Anyone who is interested in supporting our work and making sure that people that are living with diabetes, and I mean, as you can tell, diabetes really affect a lot of our people, especially people of African descent. I mean, now the disease is ubiquitous, but initially a lot of people of African descent were almost disproportionately impacted. But now it doesn't matter whether you're skinny, you're big, you're fit. You can be the most fit person in the world, but our diet these days have made it almost ubiquitous, so that almost everyone is capable of getting this disease. So the market share for diabetes is really big. And what we're trying to do is kind of take one step towards helping and, of course, eradicating the disease by making sure that the management of it is pretty seamless, because people can die, people can lose their limbs. Because if their blood sugar levels are low, you can pass out. So what our software does, it's able to notify people, like your significant other. It can notify them instantaneously. It also notifies you and tells you what to do. If your blood sugar level is low, it will say eat a fast-acting glucose, carbohydrate right now. If you cannot, it will also ask you to give us permission if you want us to call 911, especially when we can tell that it's very, very critical, and we can ping your location in case a person pass out. So we want to prevent people from losing their limbs or other complications that come with diabetes, including death, by making sure that these things are done seamlessly and that we are in control, so that they don't even have to be worried about it every minute of the day.
Interesting. Yeah, interesting. So, I mean, I think the summary of that is that you're not doing badly. You're not doing badly.
Not
I mean,
badly.
yeah, you're not there yet, but you're not doing badly. Yeah,
Yeah.
I mean, that's fantastic. So there are a lot of young people out there that want to study. I mean, you've studied more like 5, 6, 7 things, you know. So, I mean, when you say the question, what advice do you have for maybe students or early career professionals? You know, I'm talking people that are looking to pursue career at the intersection of all those things you've done: data science, biomedical science, healthcare, innovation, etc., etc. You know, because it's an elongated, your portfolio is quite large, you know. So what advice do you have for them, especially those that are in Africa, you know, watching you, Nigerian young kids in Ogun, Oyo, Bauchi, Gombe, you know, Zamfara, wherever they may be, Burkina Faso, Bobo Daloso, Congo, Kinshasa, Kisangani, Goma, wherever, Cairo, to the lowest hub of in South Africa, in Durban, KwaZulu Natal, and what have you. They will see you. What advice do you have for them? Do you have any word of advice for them, you know?
Yeah, I would say I've always said this thing. Your mind is the most fortified city
Mm,
in the entire universe or world in my view. A lot of the time when people say I can't do it, it's because they have listened to a lot of people telling them they cannot do it. As a result, then they have internalized that thought and make it their own self. So really your greatest obstacle to your own achievements and your own goals is yourself. If you commit to doing something, it doesn't matter how many degrees you want, you can achieve them.
mm,
And I don't think we are all defined by just single things.
mm,
As you can see, I started with biology and chemistry. I've had move all the way to computer science. So I
mm,
create these applications. I build websites for companies. I build systems and models monitoring GIS and biodiversity using satellite imagery data. And basically, I even created an app actually that I didn't mention. But this app, if you put in, for instance, your zip code, it will then take that zip code, put it into latitude and longitudinal coordinates, and tells you how much carbon is actually sequestered in your area, how much organic matter is within that area that you basically specify. So really, the sky is the beginning point for anyone who is committed and passionate about what they're doing. If you're passionate and you want to achieve, of course, failure. Well, it trust me, I've failed a lot of the times. I've started
mm,
many businesses that didn't work out first until I finally pivot to this, and I had to give it everything, and I had to convince myself also that failure is no option. Yes. Now, what that means, it doesn't mean that I didn't, that there weren't setbacks. Well, of course, there were certain times that I had people who were like, yeah, where would you all the way to the end? And when it get tough, before I realized I was just back again by myself, right? Trying to figure out what to do, what next to do, and things like that. It happens. But what I see is that anyone who is really, truly
mm,
passionate about what they do. Yes, one no here just means that maybe that may not be the direction you should be going. Choose and try to find out another door that may be more welcoming. So pursue your dreams. Do not be afraid to fail. In fact, that's part of the ingredients for success. If you fail, you also use it as a lesson learning thing so that you can create, in a sense, no pun intended, a fail-safe system because you will use your past failures as a way to make sure it doesn't fail again. So that's my only advice to anybody who's listening and trying to make it and may have some challenges here and there, lack of funding, lack of support from family, friends. Look, they may not be seeing it the way you're seeing it, and that's okay. And you don't have to hold any grudges against anybody. It's just that you
mm,
have a vision, and that vision is yours. And then not everyone can see it the way you're seeing it. So just keep going until they finally see it, and then they will support you. But if you give up because people didn't see it the way you do, then you
mm.
automatically just have internalized again. They are telling you that you can't do it. But if you know it's possible, you're convinced it is, just keep going. And eventually it will all fit together and works out.
Thank you so much, Ambima Buzhyason. Yes, you said it all. My summary for it, don't let anybody tell your story. Tell your
Yeah.
story yourself. If you can think it, it can be done. Take it or leave it. If you can conceive it, it can be done. There should be a lot of element of positive thinking. Paranoia will come, negative thinking will come, but nothing is impossible. I'm telling you. You know, the Wright brothers conceived the idea of flying. They tried it, they didn't succeed 100%. But
Yeah.
somebody else took it up, you know. I mean,
Yeah.
to imagine today what aviation has turned to,
Yeah.
compared to what was happening, 50 years back. If somebody had told any of us in 1970 that there would come a day you put an equipment on your head, or you look at something, and you'll be seeing a picture of somebody in Asia and wherever, you probably call it witchcraft. So things are evolving. Yeah, I'm telling you.
Yeah,
I
absolutely.
I remember when I watched the movie Shaka Zulu, and the
Yeah.
woman was thought to have died. They were going to bury her. She just had a convulsion, unconscious.
Yeah.
So she just moved her hand, and the white doctor there said, no, 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 bring her, bring her. They told, oh, that was abomination. The guy just soaked some white clothes in water, kept on putting it on the girl's head, and she came, and people, oh man, she's alive. That's witchcraft. So we learn every day, where his Slessor told us stop killing twins. Now we value twins.
Yeah.
So we'll learn. Ambima, you are a true son of Africa. We're proud of you. You're a parameter and a yardstick for measuring so much. I know you're going places. You're just scratching the surface. And to our viewers, you have all seen it. Government of Nigeria, you are listening. Countries in Africa, that's your man. He's a master, is a jack of so many trade and master of so many. Is tested and trusted. He's there in Arizona. His details will be in the chat box. So for you, if you want to contact him, he's there for you. Anybody, it's unfortunate that if he was in Nigeria, I probably wouldn't have achieved this much, but then Nigeria can still benefit from your expertise. Nigeria needs your expertise. And that's why we'll call it a wrap today. Thank you, everybody. See you next week, Wednesday. Bye. Take care.
Thank you.
Bye.